Alright, so let's talk about some right triangle trigonometry. Here I want to cover the basics of right triangle trigonometry. Let's start with the really basic. What is a right triangle? A right triangle, unlike this triangle here, is a triangle that has a right angle or a 90-degree angle in it. This angle right here is a 90-degree angle. Therefore, this particular triangle is a right triangle. And right triangle trigonometry are all the rules that govern the lengths of the sides and the size of the angles that can be in the triangle to make sure that it's a right triangle. So let's start to look at some more of this. Alright, so let's start with a right triangle. Something like this. Here's our 90-degree angle, which makes it a right triangle. And the first thing that we can do with right triangle trigonometry, or triangles in general in this case, is we can state that the sum of the three angles, so if we name this angle right here angle 1, this angle right here angle 2, and our right angle can be angle 3, we can state that the sum of the three angles, that's angle 1 plus angle 2 plus angle 3, have to add up to 180 degrees. So that's an important relationship that we can use any time we know two of the three angles of any triangle whatsoever. So if we want to relate the angles, then this is pretty easy. If it's a right triangle, we automatically know that one of them is 90. If I know angle 1, I can solve for angle 2, and vice versa. Now, you may be thinking, well, if we have a relationship for the three angles, is there a relationship for the three sides? And the answer is yes. We have a relationship called the Pythagorean Theorem. Pythagorean Theorem. And the Pythagorean Theorem relates all three sides of the triangle. Side A, which is a leg, side B, the other leg, and side C must be the hypotenuse. So the hypotenuse will always be the side of the right triangle that is across the triangle. You can kind of think about the little box here as pointing across the triangle. It makes a little arrow, and it points across the triangle at that side on the other side of the triangle, which is the hypotenuse. The Pythagorean theorem states that a squared plus b squared must equal c squared. So here we have a relationship that we can use. If we know two of the sides, we can find the third side. Okay, we can find side A if we know B and C, or any other combination of the two. So these two relationships, the Pythagorean theorem and our simple sum of the angles, gives us ways that if we know two of the angles, we can find the third, and if we know two of the sides, we can find the third. So let's do a simple example here. Let's say we have a right triangle. Set up just like this, right triangle. Here's our 90-degree angle. And let's say we know that this angle is a 37-degree angle. Now, if that's a 37-degree angle, and we know the sum of the angles, 37 plus 90 plus our other angle, let's call it angle X, have to equal 180. Well, this is pretty simple to solve. This is nice, easy algebra. We know that 127 plus x equals 180. We can subtract the 127 on both sides, and we can find out that x equals, just make sure we get this right here, 53 degrees. Okay. Now that was pretty simple to solve. We knew two of our angles, and so we had no trouble finding the third. Now we can do the same thing with our sides. We can give some values to our sides here, like 6 and 4, and we can look for y. We'll call y the hypotenuse. And again, since we know two of the three, we can use, in this case, the Pythagorean theorem. A squared plus b squared equals c squared. In this case, I've kind of said that A is 6, B is 4, and therefore y is c, the side we're looking for. So we can write this out as 6 squared, which is 36, plus 4 squared, which is 16, has to equal c squared. To solve this, we're going to take the square root on both sides. 36 plus 16 is 52. and we want to know what is the square root of 52. Well, it turns out that the square root of 52 is equal to about 7.2, which is again important because one way you can check your work here is to make sure that the hypotenuse is the longest side of the triangle. Okay, the hypotenuse should always be the longest side, and 7.2 is greater than both 6 and 4. Okay, so there's an example of our relationships for knowing two sides and knowing two angles. So what if we try a different one? Let's put it in a different color here. How about this nice orange? Okay, orange, there we go. What if we look at a situation where we have something like, here's our 90-degree angle, and we're going to put this in here as 40 degrees. And let's say I know the hypotenuse is 8. Well, I want to find this side. Okay. How do I go about finding that side? Can I use my Pythagorean Theorem, my three-side relationship? I can't, because it turns out that I don't know how long this side over here is. If I know two of the three sides, I can use the Pythagorean Theorem. So there has to be some other way to go about solving these problems when you're in the situation where you know one angle and one side. We know one angle and one side. So what we're going to do is we're going to look at the basic right triangle trigonometric functions: sine, cosine, and tangent. Okay, so let's talk about these a little bit. The trigonometric functions, known as the trig functions, what are they exactly? I find that most people don't really understand what they represent, so I want to take a minute to explain that here. The trig functions relate the angles of a right triangle to its side lengths. Specifically, two particular side lengths for each of the trig functions. There are 3 trig functions. So what we want to know here is we want to know, how are the side lengths affected by the angles that we're going to have in our right triangle? And what I mean by that is, if you have a 42-degree angle in your triangle, then in order to make sure that your triangle remains a right triangle and doesn't open up a larger angle or make a smaller angle than that 90-degree angle that's required, the other angles of the triangle will require that the side length ratios be very specific. Okay? And each of the trig functions requires or mandates a specific ratio between a specific pair of sides. So there are 3 of them. The first one is sine. And the sine of an angle relates the opposite side of the triangle, and I'll explain what that is in just a second, to the hypotenuse. Okay. Cosine. Cosine is the second one. And it relates the adjacent side of the triangle, again, to the hypotenuse. And the third one is tangent. And tangent relates the opposite side to the adjacent side. Now, these relationships have 3 parts to them. The sine of the angle, okay, because this is kind of the sine of the angle, the cosine of the angle, and the tangent of the angle, means that you need to have some knowledge or be interested in one of the angles, one of the non-90-degree angles, okay? And then the opposite adjacent and the hypotenuse and the adjacent sides over here, they represent the different sides that you may be looking for or that maybe you know, okay? So what we're going to do is, I want to make sure that you understand a little bit about how this works, okay? So what I'm going to do is I'm going to move over here, and this is your basic trigonometric table. Okay, so if you take a look at this trig table, what it has in it, it has essentially 4 columns. It is cut in half. You can see you get the first 44 degrees and then 46 to 90. 45 and 90 are a little special, and that's why they aren't listed on this particular trig table. The trigonometric table here lists the degrees, the number of degrees, the angle that we're talking about, and then it has a value for the sine of that angle, which would say that, hey, if you had, for example, a 5-degree angle in your triangle, then you would need the ratio between the opposite side and the hypotenuse to be 0.0872. So when you actually divide the length of the opposite side of any right triangle that has a 5-degree angle in it by the length of its hypotenuse, you get the value 0.0872 if it's a right triangle. Okay, the cosine there says that, hey, if you divide the adjacent side by the hypotenuse when there's a 5-degree angle in your right triangle, then you should get the value 0.9962. And for tangent, it says if you divide the opposite side by the adjacent side of a triangle that has a 5-degree angle in it, the relationship will be 0.0875. Okay, these are very specific values, and they mandate that the ratios of the sides be these values. So just to kind of make that a little clearer, if you were to look at sine, let's write this out, the sine of some angle, theta is a variable that we use to represent an angle, is equal to the length of the opposite side over the hypotenuse. Okay, so that says that if you divide the opposite side by the hypotenuse of a right triangle containing a particular angle, you should get the value that shows up right here in this column, this table. Okay? Pretty straightforward, I think. Cosine of some angle is equal to the adjacent side over the hypotenuse. So again, if you take a look at this table, if you divide the length of the adjacent side by the length of the hypotenuse of a right triangle that contains a particular angle theta, then you should get a specific value as indicated in the cosine column. And for tangent, same basic idea, particular angle, you're dividing the opposite side by the adjacent side. And then you're going to look in the tangent column right here. Okay? So what I'd like to do is I'd like to do an example here just to make sure that everybody's clear on how to do this. So let me erase some of this stuff real quick before we move on. And we'll leave our trigonometric equations over here ready to go. All right, let's move over here. And let's do an example, okay? Let me draw a triangle. I'm going to draw our triangle like this. Right angle's right here. We're going to know that this is 35 degrees, and we're going to know that this side is side of length 15. Okay, so we're going to go through and we're going to try to solve for this side right over here. I'm going to call it x. Now, there are some things that we need to do before we just go ahead and start solving for things. First of all, we need to understand what side is x. What is it that we're looking for? Well, the way that I like to discuss this is I'm going to say, well, since I know that this is my angle, the 35-degree angle, I'm going to define my sides. I'm going to name my sides based on that angle. So as I talked about before with the hypotenuse, this is the hypotenuse, since it is all the way across our triangle from our right angle. The side that is directly across our triangle from the angle that we're using, this side here, is going to be called the opposite side. Okay? If we had chosen to use the other angle, or we're given the other angle in the triangle, this angle over here, which we don't know, we could figure it out pretty easily, but since we don't know it, we're not using it, then we would define the other side that doesn't have a name yet as the opposite side. In this case, the 35-degree angle is made up by the hypotenuse and this side, which means that this side over here is called the adjacent side. Adjacent means next to, opposite means across from. So we have defined our sides, we've given them special names, and those special names happen to match the names of the sides that we need to use in our equations here for sine, cosine, and tangent. So since we want to find the opposite side, I'm going to note that the opposite side shows up here in our sine function, and it also shows up right here in our tangent function. I'm going to want to use one of those. Now, I have a value for my angle. The question is, do I know the hypotenuse so that I can solve this equation for the opposite side? Or do I know the adjacent side and can solve this equation down here, tangent, for the opposite side? Well, it turns out that I have my hypotenuse. So I'm going to use my sine equation to solve this problem. So I'm going to write that out. Sine of my angle is equal to the length of the opposite side divided by the length of the hypotenuse. So now I can kind of start to plug some stuff in. Well, the sine of theta is where we put the angle, so we're going to write the sine of 35 is the angle, and oftentimes you might need to put this in parentheses just to make sure it's clear, is equal to the opposite side. Well, I don't have a value for that, but I do have a variable, so I'm going to put x up there. That's what I'm trying to solve for, divided by the length of my hypotenuse, which I do know is 15 right here. Okay, now what? Okay, well, the sine of 35. The sine of 35 is just a value from that trig table, so I can go back to the table, and I can come all the way down here to where 35 is, and I can look up the value of the sine of 35 being 0.5, oops, that's not the right one, 0.5736. Now, 0.5736, this value is given to 4 decimal places. I personally feel that you should use at least 3. You need to stick with at least 3 of those places. The reason I say that is because when you punch this into your calculator and your calculator looks up the value for you, it will give you many, many, many decimal places worth of numbers that you could use. When in doubt, you need to keep at least 3 to stay close enough to the value that you're going to appease your teacher. So again, we can take and do 0.5736, or, as it's looked up from the table, you'd be able to look this up on your calculator. There are sine, cosine, and tangent buttons on any scientific calculator. In this case, on the TI-84 Plus, they're located right there in the center. And what you would do is you would press the sine button, and then in the parentheses you would put in your angle value, and when you hit enter, it will return for you that value, 0.5736, with many decimal places after it. For the purposes of this today, we will stick with 0.5736. So I'm going to substitute that in here. 0.5736 is equal to x over 15. Well, some basic algebra to solve this here. We can make it pretty simple by turning this into a ratio. Cross multiply, x times 1 is x. 0.5736 times 15 is approximately 8.6. So 8.6 is the required length of the opposite side of this triangle. Now, I say that very specifically as the required length because it is required to be 8.6 in order to have the correct ratio with our hypotenuse so that our triangle remains a right triangle, so that this can remain 90 degrees. If this side were longer than 8.6 and extended further, then in order to make this a right triangle, we would not be able to keep this a 35-degree angle. We would have to extend it and make it bigger. So these ratios govern and really facilitate the values that your sides have to have. So they're very helpful in using these triangles. You're going to see how we use those in class moving forward. For now, the next thing I'd like to do is kind of put down some steps. How do you do this? What are the steps you need to follow? What did we just do to kind of help get you through these in case this is your first time seeing this? Alright, so step one. The first thing we did is we chose our angle. So you're going to choose an angle. So most cases you're going to choose the angle that's given to you. It's possible that you could use our sum of the three angles equal 180 degrees to find the other angle if for some reason it's easier to use that angle. But for the most part you're going to choose the angle that's given to you. Step 2, you're going to define your sides, right? And really by define I mean name. We're going to name the sides, and they need to be named opposite, adjacent, and hypotenuse. You need to make sure you have a clear understanding of which side is which, because that's going to help you choose, number 3, choose sine, cosine, or tangent. Okay, it's going to help you choose those, because based on which sides you know, which side you have values for, and which side you're looking for, you're going to be able to find the trig function where you know 2 out of the 3 variables. Okay, 2 out of 3 variables. Okay, and those variables are the angle and then 2 different sides. If you know 2 of those 3, then you can find the third. And we'll talk about how to find the angle in just a second. Okay, step 4. You're going to plug in your numbers. Plug in the numbers that you know, being usually an angle and a side. Then you're going to use your calculator to find the value. Use your calculator to find the value of sine, cosine, or tangent. And then step 6 finally is simply solve the ratio. Okay, a little bit of algebra there. Solve the ratio to get the desired side. Okay, so there's a couple of steps that hopefully you can follow. If you go back and watch the video, and you can kind of see how we went through and followed those steps. Okay, now what if you find yourself in a situation where you're asked to find an angle, but you don't have another one? So let me give you an example of that. What if I give you a right triangle that looks like this? This is 90 degrees. I tell you that this side is 7, this side is 9, and I want to know what this angle theta is. Now it's a little bit different situation. Okay, we kind of looked at when we started with, hey, I know 2 sides, I can find the third, and I know 2 angles, I can find the third angle. And then we kind of moved to, well, what if I have one of each? Can I find some other stuff? And the answer was yes. And now we're kind of at a situation where I have 2 of the sides, which means I can easily find the hypotenuse, the third side over here, using the Pythagorean Theorem. But how can I use these 2 sides in order to find the value of that angle that's missing? And the answer is we can kind of do the opposite. Okay, we're going to do the inverse trig function. Okay, and essentially what that means is that if I can determine the ratio, then I can go back to my table and I can look up the value of the ratio and find out what angle it came from. So I want to go back to that table for a second. And if we come back and we look at this table here, what your calculator does when it gives you the value of sine, cosine, and tangent for a particular angle is it comes to this table and it looks it up. It says, hey, Mr. Garstka just punched in his calculator that he wants to know what the sine of 74 degrees is, and it's going to go down to 74 degrees right here, and it's going to look in the sine column, and it's going to report back 0.9613. And I'm going to be happy because that's the value that I want. Well, couldn't we ask the calculator to do it the other way? What if I said to the calculator, hey calculator, in the cosine column, where is 0.4848 and what angle does that come from? And the calculator can locate 0.4848 right there, and it can report back to me 61 degrees. And now I'm able to find out the angle because I know the ratio of 2 particular sides. But what I have to make sure that I'm doing is I'm asking for the value from the right column, which means I need to use the right side values when I do this. Now, on your calculator, when you do this, you're going to use second, and then you're going to hit sine, cosine, or tangent, depending on what sides you need. And the symbol for inverse is a little raised exponent -1. Now, don't be confused, it's not an exponent. And the way you're going to put this in your calculator is that sine of -1 will be equal to the opposite side over the hypotenuse, and that will give you the value of the angle by looking up this ratio that shows up in the table. The other way we could do this is cosine inverse is equal to the adjacent side over the hypotenuse, if those are the sides that you know, and it will report back the angle that you want. And finally, tangent inverse would be the opposite side divided by the adjacent side. And that's going to be set equal to, or report back to you, the angle that you want, theta. So again, it's important that we know and understand which sides we have by kind of going through the same process we talked about a few moments ago. So the first thing I'm going to do here is I'm going to kind of try to follow those steps, and I'm going to define my sides. Okay, I'm going to name them, but first I have to choose the angle. Well, this is the angle I want to use, so I think that's a clear choice. I've chosen this angle, and I know a side is length 7, and I know a side is length 9, but I need to know what side it is. So if I use my definitions here and say, hey, across the triangle or opposite from the angle that I want, the 9 must be the opposite side. And that means that the 7, since it shares a side with my angle, must be the adjacent side. So I know opposite and adjacent. And if we remember from before, tangent gives us a relationship between the opposite side and the adjacent side. So I'm going to want to use inverse tangent here. So I'm going to write this out as tangent raised to the -1, which again is not an exponent. And in it, I'm going to put my opposite side value over my adjacent side value, and it's going to give me the angle theta. Okay? So I can put this in one of two ways. I can put this in as tangent inverse of the opposite side is 9 over the adjacent side is 7. Okay, equals some value, I don't know what it is yet. Or I can put this in as tangent to the -1 of, and I can actually put the numerical value 1.29 in. 1.29 is 9 divided by 7. Either one of these will give me the same correct value of theta that I want to know. And when I put this in my calculator, knowing two sides, the calculator will look that ratio up for me, and it will tell me that theta has to be equal to about 52.2 degrees. Okay. Oops. Okay. So what we've covered here today, and we've seen a few examples of, is we've covered that the sum of the three angles of a triangle, angle 1 plus angle 2 plus angle 3, have to all add up to 180 degrees. And we can use that to help us find a third angle if we know two of them. We discussed that a squared plus b squared has to equal c squared. C must be the hypotenuse of the triangle, and this relationship is called the Pythagorean Theorem. The Pythagorean Theorem, a squared plus b squared equals c squared. This is useful because I'm able to find any side if I know the other two. I can find the hypotenuse, I can find either of the two legs as long as I know the other two sides. And then we discuss special situations where maybe you know one angle on one side, you don't have two angles and two sides, and you know it's a right triangle. In those cases we can use that the sine of theta is equal to the opposite side divided by the hypotenuse. Or, depending on what side you know, you could use cosine of theta is equal to the adjacent side divided by the hypotenuse. And finally, if you happen to know the opposite side or the adjacent side and want to find the other, then you could use tangent of theta equals opposite over adjacent. This is a little cheat sheet for you here at the end.